And so after this, we have a discussion period for 15 minutes, I believe.
Yeah, as long as we can. So I want to open the floor up to any questions. All right, I will take the chair's prerogative and actually ask the first one, and that would be of you, Lyndon. So these were very nice modeling activities you were doing. You were looking at lava tubes, and they seem to have some fairly well-defined geometry. So I'm wondering, what degree of disorder can you handle, or how important is the actual geometry of the tube in your simulations?
Thank you for the question. That's a very good question. I have done some simulations of very irregular shapes as well, some more triangular and some more square. Most of the models have been semicircular, as that is what we would expect. But in order to go more towards complexity and more towards reality, we will also add in some rounding of the sharp edges of the bottom of the tube and the tube floor. More on the how accurate does it need to be? That's a very good question. That would depend on station spacing, I would say, which is also something that we're looking into, because the more widely spaced the stations are for the seismic and the GPR, the less resolution you will have. So if they get higher resolution, more finely spaced stations, we would be able to handle more irregularities and more anomalous tube structures than we would for more widely spaced, say 10-meter spacing between stations.
Could we see the chat questions? Because I think there might be some in there. Okay.
It would be on your screen here too. Okay. Yeah. Go ahead, Nick, please.
Nick Schmidt, University. Is it on? Can you hear me? Okay, there you go. Nick Schmidt, University of Maryland. I have a question for Aisha, and she's giving me the eye. You skipped over one of your slides there at the end, which talked about some possible hypotheses for these gradient-like classification events. Do you want to comment on that a little bit?
Oh, yes. I really wanted to actually include that in my presentation. So I'm glad you asked this question. But one of the possible avenues that we're kind of exploring with this gradient subgroup is that it could be due to different times of occurrence, especially with regard to lunar positioning. So that last graph that I wasn't able to spend a lot of time on was comparison of these events in time to lunar apogee and lunar perigee. But what we're seeing right now is that there isn't a strong relationship that I can see so far. But this is also very preliminary data, and that's something that I want to investigate further. Thanks, Nick, for asking that question.
Have any more questions? Well, I'm going to display my ignorance here. So please forgive me on this question. But so when I see a plot where I have time and frequency, I think of doing Fourier transforms. Is that ever used in analyzing seismic data? Okay, so why is this superior to doing Fourier analysis?
I think the idea of like, if there's a Fourier analysis, you get the power spectra, right? So they can, you can basically take power spectra of an individual like seismogram of a deep moonquake event. But where scattering transforms give a little bit more of an advantage is that it allows to kind of give you the relationship of these patterns in time. Whereas, so it's I guess a comparison to it might be a spectrogram, honestly, if you think about it like that. Yes. So this is something that it's relatively new. I think the first time a paper about scattering transform has been published was in 2011 or 2012. And it was able to, in conjunction with machine learning algorithms, be able to classify different audio signals very, very quickly. So this was the kind of work that I want to do with deep moonquakes, even though there are different restrictions because there aren't as many deep moonquakes that you could use for a machine learning algorithm. But yeah, that's where the advantage comes in.
Thank you. Very good. Are there any further questions from the audience? We have none on we're not zooming in too well here. Okay, so on that, I want to thank all of the speakers for very excellent talks. And with that, we'll close the session here. Thank you very much.